Let's see stack implementation with linked list. This is also very similar to array implementation of stack. At compile time, memory will be allocated automatically for arrays, but while implementing stack with linked list, we need to allocate memory dynamically. Suppose we want to add this element 5 to our stack, we need to allocate memory on the heap. This create node function will allocate memory on heap by using this malloc function. This malloc will return the base address of newly allocated block of memory that will be saved within this pointer new node. Suppose this newly created node address is 1000, then this new node will be assigned with that base address 1000. This new node pointer is pointing now to this newly created node on the heap. Each linked list node has two parts. One is data part and another one is the link part, which will hold the address of the next node. We will store this 5. If function call is made for this push of 5, then this 5 will be passed to here. With this 5, this create node function will be called. So this 5 will be assigned to this local variable element. So this 5 will be stored in the data part of your newly created node. Initially this link will be null. This create node function will return new node address that will be stored in this pointer in this push function. So now this new node will contain the address of this newly created node 1000. Global variable head is also null initially. Here this top is assigned with head value, so top will also be null. Here head is null, so which satisfies the this if condition. So we need to make this newly created node as head by copying contents of this new node pointer into this head. Now head will contain address 1000, means now we made this newly created node as head. If we try to perform this push operation, this push function will be called. Head is having address 1000, same will be copied into top also, so top will also be 1000. This create node function will create new node and it will add this 6 into the data part, and initially link will be null and it will return that newly created node address to this pointer. So this NN will contain this address 2000. See here head is not null, so this if condition will fail and it will enter into this else block. This newly created node will be placed on top of the most recently inserted item within the stack. So we need to find what is the most recently added item within the stack by traversing from the head. So how can we identify the last node within our stack? For the last node, this link part will be null. And for all other nodes, this link part will not be null. It will contain some address. Since we can access linked list sequentially, we need to start from head and find the last node by traversing the linked list. Here top and head both are pointing to this node. Here head is global variable. We should not change the contents of head. If we change, we will lose the address of the first node within our linked list. So we are using top for traversing purpose. Here top next is null, so this is the last node within our stack. So we will add this new node on top of this node. So this top next will be assigned with this new node address. So now stack will be like this. This first node link part will contain the address of this newly created node. If we try to add one more item 7 into stack, this create node function will create new node. Suppose its address is 3000. It will be stored in this pointer NN. Initially this top and head pointing to the first node within the stack. We need to find the last node within our stack. If the link of the node is null, then that would be our last node. If link is not null, we have to increment top while top next. not equal to null, top will be incremented here. Top next is 2000, which is not null, so we have to increment our top. After completion of this while loop, this pointer will be pointing to last node. Here is the last node because its link is null, so top will be pointing to this last node. We need to assign this new node address to this top next field or link field. Now these are our stack contents. This top next holds the address of the newly created node. Let's see the pop operation. We need to remove most recently added item from the stack. Here this is our last node. We need to remove this from the stack. If we delete this last node, we need to update the link of this last but one node to null. So here we need two pointers. One is top to hold the top node and another one is to hold previous node of the top. Let's call it as pre underscore top because we need to set the link of this previous top to null. Initially, this both pointers top and previous to top will be assigned with head. Head is 1000 here, so top and previous top will be holding same 1000 here. Now all these three pointers pointing to starting node within our stack. We have to remove most recently added item, means top, from this stack. So how will you identify this top? If node link field is null, then that node is top. And how can we identify previous node of top? Previous node of top will contain address of top node. Suppose this is the top and this is the previous top. So previous top node link will hold the top node address. So anyway, top node will hold the null in link part. So checking condition for previous top is previous top next will be null. Let's check here. This previous top next holding address 2000, its next address is 3000. So this while condition is satisfied. So pointer previous to top will be incremented. Initially previous top was 1000. After increment it would be 2000. So now it will be pointing to this second node. Again this condition will be checked. Previous top next, that is 3000, and its next is null. So this condition will fail. It will get out from this loop. We need to update top. Previously it was 1000 pointing to starting node. That will be updated with previous top next. This is the previous top now and its next is 3000. So top will contain the address 3000 now. Top will be pointing to this last node. We identified this top element. We need to delete it from the stack because we did dynamically allocate memory. So we need to free that memory with this free function and we need to set this link value to null. After these two statements, our stack would be something like this. Let's perform one more pop operation. Here head is not null, means which contains the some address. So this if block will not be executed. Here head is not null, so else block will execute previous top next value. Here this is the previous top, its next is 2000 and its next is null. So this condition will be failed here. So this while loop will not be executed, means this previous top will not be incremented. It will be at same position. This top will be updated with this previous top next value. Previous top next value is this 2000. So this top will be updated with 2000. So now top would be pointing to this last node. We need to delete top and update the link of last but one node, this one, and we need to set this one to null. Now in stack only one element is present. Let's perform one more pop operation. Here head next, which is null. Head is pointing to this node, so its next is null. This if condition will be satisfied, so this if block will be executed. So set this head value to null. Here it will be set with null and delete this node. See here this head is set to null and we need to delete this top node. After deleting that node, stack will be empty. This is complete program for implementation of stack with linked lists. stdlib.h is a standard C header which defines dynamic memory allocation functions like malloc, cloc and free. This is the linked list node structure. Here we are using single linked list. So we have one link. Here we declare head as a global variable. Initially head is null. This is the linked list node creation function. Here malloc is used for allocating block of memory at runtime. This is the push function. If linked list is empty, we need to make new node as head. If linked list is not empty, it will come to this else block. We need to find the top element and place this newly created node in top link or top next field. This one is the pop function. Here we need to cover three conditions. If stack is empty, we cannot perform pop operation. So we have to raise the error stack is underflow. If only one node is present in stack, we need to make this head as null and then we need to delete the top element. See here, that last element is stored within this top. So we can delete that top element. If linked list has more than one element, we will come into this else block. Here we are identifying previous node to top. So top would be next node of previous top. We need to delete the top and we are setting the previous to top next link as null. See here, we are not returning top element, so return type of this pop function is void. In array implementation of stack, we did return top element from pop function, so its return type was int. You can implement either way, it's your choice. And this one is the display function. It will print the contents of the stack. If we execute this program, here we are performing three push operations. This display function will print the stack contents. So here we have stack with 5, 6 and 7. Then we are performing pop. After that this pop will remove the top element. Here top element is 7. So this will be removed. Then if you print the stack contents, we will get 5 and 6. Next second display function will print this 5 and 6. After this push operation, then stack will have 5, 6 and 8.